Going on now to Chapter 7. Here we're going to be dealing with exponents and radical functions. And in Section 1, radical expressions, functions, and models. Here are the topics and some of the techniques and skills needed for mastery. And we'll start off by filling in these first 6 definitions with these terms. So hopefully again, the lesson you've already had or will be having, and this might be background. Keep in mind I've also done a whiteboard video on this. Generally in the whiteboard videos I don't do the vocabulary because it's just too much to write on the board. But I do work some of these things out, and sometimes seeing it along with seeing it here is a helpful way to practice for mastery. So as we go over these, so the number c is a square root of a if c squared equals a. And we'll give you some examples of that. And the principal square root is the non-negative one. A square root of any whole number that is not a perfect square is irrational. And this goes back to our number system of real numbers, back to Chapter 1, where we went over what irrational numbers are. So if you have the square root of 4, 4 is a perfect square, that's going to be 2. But then if you take the square root of 3, 3 is not a perfect square, so the square root of 3 is irrational. All right, a number c is a cube if c to the third equals a. And we'll give you examples on that. Now, often when you see the radical sign, and I think I skipped 4, I'll get back to it. This is the radical sign, and what is under the radical sign is called the radicand. And in this little notch here, there is often a number. Well, often there isn't, and by the way, if there is no number there, the number 2 is implied that we don't write. But any number higher than 2 that we put here in this position is referred to as the index number. So you might say, well, what's the index number of a radical that doesn't have one? Again, it would be 2. And 1 is never there. The 2 is the unwritten. Okay, well, let's go on. So for number 7, what they're asking is take the square root of 64. Now that's a perfect square. So I don't know if you remember, but we get a positive 8. And we also get a negative 8, that if we squared would be 64. Keep in mind the positive 8 would be the principal square root. And here we're taking the square root of that, which would be plus or minus 70. And then here they're asking us to simplify. Now, because the negative is outside, it ensures that whatever fraction we get will be negative. So this is going to be The square root of 225 is 15, and 169 is 13. And again, the negative sign for sure because of that negative outside. So here we're interested in the principal square root is 16. The principal square root is 0.3. And then again, because of the negative, and then the principal square root of that is 0.11. Now remember, if you multiply 0.11 times 0.11, you're going to end up with 4 decimal places. Here, 0.3 times 0.3, 2 decimal places. So if you're not careful of where the decimal place is going to be, you might have an error there, so be careful. All right, going down to number 13, it says identify the radicand. Well, the radicand is just what is under the radical sign. And the index number, since one is not written, is a 2. Now for number 14, the radicand is what is under the radical sign. So it's this and this. And the index number is 3. Okay, now what we will do for number 15 is I will set this up for you using a method that might be useful. Now for these, we're taking these values of x, and we're using that t-chart from way back in chapter 2. So let's do the first one. If x is 5, 3 times 5 is 15. 15 minus 12 is a 3, so you get the square root of 3. Now if x is 4, 3 times 4 is 12. 12 minus 12 is 0. The square root of 0 is 0. Now if x is 0, 3 times 0 is 0, and you're left under the radical sign with a negative 12. Well, we have said that in order for something to be a real number, you cannot have under the radical sign with the second power, that is the square root, a negative, because there's no two numbers that when you multiply it together give you a negative. So this number does not exist as a real number. A negative 5, again, this becomes a negative 27. That doesn't exist. And the same thing applies here. If you apply a 5 there, this is a negative 25, a negative 15 under the radical sign. It doesn't exist. If it's a 3, this becomes 3 squared is 9. 10 minus 9 is 1. So you get the square root of 1 is 1. And it goes on to give you these others. Okay? Now here they're asking us to put absolute values when they're indicated. So here we're going to take the square root of 100, which is 10. And there wasn't any question about whether or not that was a negative 10, although to me that's a little iffy. But anyway, the square root of m to the second, keeping in mind there's a 2 there, and often a shortcut is just to take that 2 and divide it into this, and that will give you the m. And again, we didn't know if those were negative, so the book is putting the absolute value there. I don't usually take off for that, but I'll give you what the book gives. Now here, this is a perfect square trinomial that we factored into that. And again, there's a 2 there. So if we divide this by 2, it just becomes this radicand. And they're putting that into absolute value. Now, if the index number is 3 and we're taking the third root of something, a negative can be under the radical sign. And that then is the cube root of a negative 8 is a negative 2. And this is a 3. Okay? So actually it's a negative 2/3. And here, again, if the index number is 6, you can just put that 6 right there. And you'll see this in a later section, this shortcut. And it just becomes 5x. And again, if it's a variable part, we put that in absolute sign. Now, for this one, again, there's a 2 there. So if we divide that by 2, we get p to the 25th. And we're not using absolute signs there. Now here is a case where you have a radical of negative 4. This is not a real number. So this number does not exist. Now here they want us to simplify and perform by raising negative quantities to even powers. So the square root of 81 is 9. And again, we're just dividing this by whatever the index number is. And that gives us 9c. Now here, this is a perfect square trinomial, which is 2x minus 7, the quantity squared. And when we take the square root of that 2 and this 2 sort of cancel out, and it just becomes that. Your instructors will be giving you other hints or patterns to follow on some of these. And what we see here now, again, the negative is there because it's outside the radical. And then the third root of this is 5. This is the fourth root. And the fourth root of 10,000 is 10. Because 10 to the fourth would be that. And here, to have the negative is good because this is an odd root. And the third root of a negative 8 would be a negative 2. And the third root of t to the third is t. Again, the 2 is there, so we're going to divide the 30 by 2 and get x to the 15th. All right. Before we go on, by the way, I want to correct this little error here. There is no fourth power, it's just 10. The fourth root of that is 10. Now, if you take 10 and raise it to the fourth, you get to 10,000. I made a little error there, and I caught that one. Okay, for this one, what we're doing is to follow a pattern, little t-chart, put our values in there, and then do substitution. So if x is 0 here, this will be the cube root of -1, which is a -1. Now you'll notice in this particular t-chart, there are no values that are excluded, as we have down here. Does not exist. I shortened it up here. Does not exist. And you might say, well, why? Well, anytime you have a third root as an index number, you can have negative results under the radical sign. If they are 3, 5, 7, an odd index number, you can have negative results. But in number 30, if you put in a negative value, it ends up as a negative value under the radical sign, you can't have it because this is an even number. So that's why no does not exist would come in when you do your substitution. Okay? And these just take time to work them out, and that is the rules that you operate under. Now, before I start to write on these, I'd like you to see if you can understand what they're asking. So they want you to find the domain that would be described there. So remember, some numbers do not exist. So if we have an even index number, as we have in 3 of these, then all we do is equal our radicand to 0 and find out which value of the radicand makes it a 0, and then any numbers below that, depending on the sign of that, sometimes it will be above. In fact, these two cases, it's what's above will be okay. What would be below 0 would not be okay because it would make the radicand negative. So just to give you what's going on here. Here there are no qualifications because it's an odd number. So these are all real numbers. But these, where they have a positive index number that's even, I got carried away there, an even index number, they do have limitations or restrictions. So as we go through these, we're going to equate this to 0. So x has to be greater or equal to 4. That's our domain. Equal this to 0. T is greater or equal to a -3. Now it's starting at -3 because if t were a -3, this would be 0. That's fine. Here, because it's an odd index number, it's all real numbers. Now number 34 is a little tricky because our x value itself is negative. So we solve that and we get x has to be, reading it this way, x is less than or equal to 2. Because, let's just put that 2 in there. So if x is 2, we get 4 minus 4. Now if x were 3, that would be larger than that. And we put the 3 in there for the x. -2 times 3 would give us a -6. So any number larger than 2 is going to make this, because of the negative sign there, a negative value. So this is the domain. Negative numbers are good because negative times a negative make that a positive. That's why we have negative numbers up to 2. If the number is larger than 2, it makes what we have under the radical sign negative, and those are excluded. Now this is similar to what we've done. Now we just equal the radicand to 0. I'm going to transpose the x, and I get x is less than or equal to 7. So as long as x is 7, then this would become a 0. That would be okay. But if x is greater than 7, that is, suppose x would be an 8, then 7 minus 8 would give this a negative 1 under the radical sign. Those numbers do not exist. So that's our value. So again, similar to the previous one, it will come up from negative infinity up to 7, and 7 is included in the set. Now if I put that into my TI 83 calculator, when I graph it, it looks like this. Now, what would our range be? Well, this is starting right here. So our range now starts at 0, and it continues up to positive infinity. And we'll do this one now too. Now, since x here is squared, if it is a negative value, that's fine. It's going to always be positive coming out of this. So our domain is from negative infinity to positive infinity. And if we put that in our calculator, it shows up as a y-intercept of 6 here, and this opens up downward because it's negative, and you get this parabola. So what would the range of this be? Well, our range starts with values coming up from negative infinity up to and including a 6. And I believe that concludes this lesson. Yes.